First of all, thank you for clicking on this video and welcome to my channel. Today we are going to see the next topic in the data structure subject, that is AVL tree rotations. We'll see what are the operations in the AVL tree. First operation in the AVL tree is rotations. So in AVL tree, after performing every operation like insertion, deletion, after that we can check the balance factor of every node. That is, the balance factor may be 1, -1 or 0. If other than these three values, we can consider that the tree is imbalance 1. So here, if you want to balance the AVL tree, at that situation we can use the rotation operations. So if every node satisfies the balance factor condition, then only we can call the tree as balanced binary search tree, or we can call it as AVL tree. So here we will see, so rotations or the operations are used to make a tree as balanced one. So here the balanced one means if the tree is balanced only, we can say that the tree is AVL tree. If it is imbalanced tree, we cannot call the tree is AVL tree. Here there are the two types of rotations are there. First rotation is single rotation, second rotation is double rotation. In single rotation, the two categories are there. First one is LL rotation, that is left rotation, and next one is RR rotation or R rotation, that is right rotation. And here in double rotation also there are the two categories are there. First one is LR rotation, that is left right rotation, and the next one is RL rotation, that is right left rotation. So now we will see the rotations with examples. First one is left rotation. Here when BST become imbalanced or unbalanced one, then due to a node is inserted into the left subtree of the left subtree. Here you can see that if left subtree of the particular tree is imbalanced one, so at that situation we can apply the rotation, that is LL rotation. So here the LL rotation is clockwise rotation, and this rotation is used to make a tree as balanced binary search tree. And here we can see with the example of this how we can perform the left rotation. Example, here we can see there are the left subtrees there, and nodes are C, B and A. Here first we will calculate the balance factor of A. The balance factor formula is equals to BF is equals to the height of the left subtree minus height of the right subtree. So here we can calculate for this A node there is no left element and right element. That's why we can consider the balance factor is 0. And next one, we will calculate the balance factor of B node, that is here left subtree is there and there is no right subtree. That's why we can take the balance factor is equal to height of the left subtree is 1 and height of the right subtree there is no element, there is no nodes. That's why we can consider that 0. So balance factor of the B node is 1, and here we can see the next node, that is C. So balance factor is equals to height of the left subtree. Here we can see the left subtree, that is 1 and 2. So 2 minus right height of the right subtree, there is no element, so we can consider that as 0. So now the BF become as 2. Now whenever we will get other than -1, 1 or 0, that the factor or that the balance factor is 2, then we can say that is imbalanced tree. So to make it as a balanced one, and this direction is left side, so we will perform the left rotation, so that is LL rotation. Here from the B onwards and we can forward to the right side. So what will be happen whenever we will apply the rotation, that first what is C is there, that will be moved to the clockwise direction. So like this it will be moving. So here the C will become as the right element and B is become as the root element for the remaining two. Why? Because here which node will be at the middle of the subtree, that node become as a root node and remaining two will be as the childs for this node. So after applying the LL rotation, we can calculate the balance factor of A node, that is 0, and C node, and next we will calculate the balance factor, that is B is equal to 0. So B at the B node, the height of the left subtree is 1 and height of the right subtree is minus 1, means 1 minus 1. So here the balance factor has become as 0. So like this we can apply the left rotation. Now we will see the next rotation, that is RR rotation, means right rotation. When a BST or binary search tree become imbalanced one due to a node is inserted into the right subtree of right subtree, means the node is inserted at the right subtree, then we can perform the rotation as right rotation. So here whenever we will perform right rotation, that the rotation is an anti-clockwise rotation, and this rotation is used to same as it is used for balancing the binary search tree. So here we can see the example one. See, there are 3 nodes are there, that the tree is totally, that is at right subtree, and here 3 nodes are there. First we will calculate the C node balance factor, that is BF is equals to height of the left subtree minus height of the right subtree. Here there is no left subtree and there is no right subtree for the C node, so we will consider it as 0. And next we will calculate the balance factor of B, and here we can see, and height of the left subtree means here there is no node, means we can take it as a 0, minus height of the right subtree, one node is there, so 0 minus 1, the B at the B value we will get it as minus 1. And next we will calculate the balance factor of A node, that is height of the left subtree. At B node, but at A node there is no left subtree, so we can take it as a 0. And at the right direction we have a 2 nodes, so that's why we can take it as minus height of the right subtree is 2. Now the value of this is minus 2. So here we can see the at C node we have 0, means balance factor consists of either 0, minus 1 or 1. We will say that the subtree is called balanced one, but at the node of A the balance factor is minus 2. So that's why here we have to apply the rotation. So first we are going to apply the rotation. We have to check which direction that the insertion is completed or insertion is done. So here that is of right side, so we can consider first C is inserted at right side and B is inserted at right side. So that's why we can apply the rotation. The rotation will move to the anti-clockwise direction. So see here, whatever the middle element is there, means B, so that will be become as a root for remaining two, and A will be moved to the left direction and C will be as it is. So next, after applying the right rotation, the tree will be come like this. After that we can calculate the balance factor. For A and C there is no children, so we can take the value as 0 and 0. And at B node the balance factor is left subtree is 1 and right subtree is minus 1, so the balance factor is 0. Now we can check the balance factor value. For those 3 nodes have a 0. So this is tree comes under balanced binary search tree. And next one is LR rotation. So that is left and right or left right rotation. So this is the LR rotation is called as double rotation. So first we have to see how what rotations we have to perform. First you can see LR rotation is equal to RR rotation plus LL rotation. So here first we have to perform the RR rotation. After that we have to perform the left rotation. Whenever we will perform 2 of rotations, then only the tree will become as balanced one. So that the reason this rotation is called as double rotation. And here we can take it as an example one. See, the root node is C and the left subtree of the node is A and right subtree for A is B. So now we have to calculate the balance factor. For B there is no children, we can consider it as 0, and for A there is no left element, but here right side one element is there. Height of the left subtree is 0 and height of the right subtree is -1. So the total balance factor is -1. After that we can calculate the balanced factor for C. So here we can consider it as, for the height of the left tree is 1 is there and 2 nodes are there, A comma B. So we can take the value as 2, and height of the right subtree there is no element, we can take it as 0 and balance factor is 2. Now this tree is imbalanced one, that's why we cannot call it as AVL tree. So we have to perform the rotations. Those are, we can see which type of rotation is it. So first we have to check the direction for it. So like this we have to check. So first from the B onwards we have to check that is inserted at the right side of A, and A is inserted at the left direction of C. Now we can take it as that is LR rotation. So if it is reverse of it, we can say that is called RL rotation. For this one, first we have to apply RR rotation. So here RR rotation means we have to take the R and here we have to perform the R rotation. So what will be happen here? The A will move to the anti-clockwise direction and B will become as a root for A. So here we can see C is as it is, and which rotation we are applying. If we are applying a right rotation, that what is the child element is there, that will become as the root for the A. So here B will become as root for A, and we can take the next direction, that is LL. So after performing the R rotation only, we can apply the LL rotation, that is clockwise rotation. So here C will move one step to the right side, and B, which one is the middle of this rotation, that node will be become as root for the remaining 2. After that we can calculate the balance factor for them. So here we can see A have a 0 balance factor, and C also have a 0 balance factor, and B is also as 0 balance factor. So that's why this tree is a balanced AVL tree. Next rotation is RL rotation, that is right left rotation. Means here also this is also 2 types of rotations are there. First we have to perform LL rotation, after we have to perform RR rotation. Now here we can take one example one. See here, and this is the small subtree. First we have to calculate the balance factor of B, that is 0, and balance factor of C. So left side one node is there, so height of the left subtree is 1, and right side there is no element, so we can consider it as 0. So the balance factors become as 1, then there is no need to balance. And whenever you will take a node, we have to see left height of left subtree is not there, so we can take it as 0 minus right subtree. There is 2 elements are there, C and B, so that's why the minus 2 will come as a balance factor. Now we can see here minus 2 is there, minus 2 is not belongs to balance factor, so we have to balance that. The tree means we have to apply the rotation first. Before that we have to check the directions, means then only we can take it as which direction we have to apply the rotation. First we have to see the last node, that is which direction is it. This is the left direction for C, and after that we have to check C is in the which direction of A, that is right direction. So here we have to apply the rotation, that is RL rotation. See now how we can apply the RL rotation. First we have to apply the which one is last one, that is L is there. So first we have to apply LL rotation. So here we can see how we can apply it. From this B we have to apply L rotation. So this is the C will becomes to, this will move to the right direction, and in the place of C B will become, so this like this it will become. After that the B and C will come to the right direction. So now we have to write the direction, that is RR direction. So now we have to apply the RR rotation from A. So A will move to the right left side, and which is the middle element is there, that is B. So that will be become as a root for remaining 2. See here, like this it will come. After performing rotation we have to check the balance factor. So A have no children, so we can write it as 0, and C also there is no children, so we have to write it as 0, and B have 2 children, so height of the left subtree is 1 minus height of the right subtree is 1, so 1 minus 1 means 0. So balance factor of for this tree is 0 0 0, so this is the balance tree. Now it is called as AVL tree. Like this we have to perform the rotations in AVL tree. And thank you for everyone.